Welcome to the another video on the basic electrical engineering. In the first video we have covered some of the concepts, Ohm's law and node branch and loop and Kirchhoff's law, and now we are discussing about the series resistor and voltage division. If two resistors are in series R1 and R2, how the voltage is going to be divided. So from these two resistors we can have Ohm's law, from the Ohm's law we can say what is the resistors over what is the voltage and what is the voltage across here and what is the voltage across resistor R2, and by using the KVL we can find the sum of all the voltages in this closed path, and then we can find what is the current, common current. Obviously the current is equal to R1 total voltage V divided by R1 plus R2, and where R1 and plus R2 is nothing but R equivalent. Now finally our objective is to know what is V1 is nothing but I into R1. So I is now calculated, and which is equal to V by R equivalent, and we observe that V1 depends on the R1, where R1 is the resistance here. So what we observe from here, the V1, the voltage across a resistor R1 depends on the magnitude of R1. So if R1 is higher than R2, if R1 is higher than R2, so V1 will be higher than V2, and that is the proportion in which it is being divided, right? So here we can say V R1 divided by R1 plus R2. So if two resistors are there, and suppose there's a 100 volt, if this is a 60 ohms and this is a 40 ohms, the voltage over here will be of 60 volt and the voltage here will be of 40 volts. In this proportion it is being divided. Similarly, we have two resistors in parallel, so there is a current is divided, and if the main current is I, what proportion of the current is flowing through the R1 and what proportion of current flowing through R2. From the KCL at this node we can find the sum of the currents, and from the Ohm's law we can say whatever the same voltage is there, so we can have this relation and we can write what is the value of current. So from that we can get what is the equivalent current or current flowing in the common branch. Now the current which is flowing in the individual branch over here depends on V by R1. We can say I1 is equal to V by R1. So V by R1, so substituting the value of V, what we observe here is that I1 is proportional to, so current here is proportional to the R2 resistance. So if this is like 100 amperes is flowing somewhere, and this is suppose this 40 ohms and this is the 60 ohms, so current here will be like 40 ampere and here the current will be 60 ampere. It is like the current is divided depending on the resistor on the opposite end or the other side end. So the current here will be 40 amperes and here will be 60, here will be 40 amperes and here will be 60 ampere, depending on whatever depending on the resistance value. So the current on the one branch depend on the resistance of the other branch. So conclusion, some of the cases are that if the one branch resistance is 0, the current through this will be obviously full current will flow through it, and the other side the current will be 0. And the current, if this is infinity, all the current will flow from the other side, and here the current will be 0. So you have got another cases here that if resistors look like this, so here the resistors are in this fashion, and that makes a problem to us that how to find the equivalent resistance. So if possible, I can make a resistance look like this. In this fashion, so then it is possible that these two are in series and we have got a two branch network in parallel, and then we can like relate these two and find out the equivalent resistance. So to do this, what we have did is a delta connected over here is we was delta connected, and we would like to convert that into star, or if there is a star connected we would like to have converted into delta. So this conversion is possible. Let us acquaint ourselves with how we are going to solve it. So in this case, what we see, this is a star network and this is a delta network, because it looked like a star and here it looked like a delta. This is star is nothing but also look like a T, and this delta is also look like a pi. This is a pi network. Here the nodes are separated, but it is sharing the common node, and this is represented over here. Instead of making like 2 and 4, we can have 2 and 2. It is more suitable. Otherwise, you say this is a node 2. And notification is that between 1 and 2, if a register is connected to 1, we can name it like R1. If it is 2, we will name it like R2. Similarly, if it is noted between 1 and 2, we say R12. If it is between 2 and 3, we say R23, and 3 and 1, it will be R31. And so in Delta, we have a double notification, and in Star, we have a single notification. With this, let us proceed. Suppose we are finding the Delta to Star conversions. So whatever the circuit network like Star or Delta, the resistance between 1 and 2 in both the case must be same. If the resistance is same, here the resistance is sum of these two, and here the resistance is two branches there. So these two are in series and this is in parallel. So if it is parallel in case of Delta, so you can say AB by A plus B. So just add these two and multiply with R12. So that is what we obtain. And in Star, we'll have just sum of these two, R1 plus R2, we get obtained. So finally what we get two resistors, then done. And another notification we get to use is that just say this is as R of Delta, because this is adding all the resistance of the Delta side, so that we can easily notify these terms. So what we get is that if we add these two, we can say these are equal. Then R12 is equal to between 1 and 2, not 1, 2. Between node 1 and 2, we have R1 plus R2 is equal to this term, R2 plus R3, R3 plus R1 will get the terms like this. How we have to do? We just add these two terms and subtract with these terms. So what is there? This 3 and 1 will cancel here, and here we will have 2 R2. In this case, you will have got these two numbers are common. These are the double numbers you will have. These two numbers get subtracted, and the denominator will be remain as it is. So you have got R2 is equal to in this term. So what is a unique thing you get here is if 2 is there, 2 is common both the resistors here, and 1 and 3 add up. If 1 is there, 1 is common in both the things, and 2 and 3 is add up. 3 is there, 3 is common in both, and 1 and 2 is common. 1 and 2 is there add up. So here R1, R2, R1 and R3, you can get individual star terms from the delta equivalent. So if delta is known, you can find its star equivalent. Other way is that you can have R1, R2, R3. Also you can say that R1 is nothing but multiplication of R31 with R12 and divided by sum of all the resistors. So you can write each resistor in the star network is a product of the resistor in the two adjacent delta branch divided by the sum of the three delta resistors. Right? So this is the equation. It is just given in the conversion rule is that if R1 you want to find, multiply R31 R12 divided by sum of all the resistors. Similarly, we can have like a star to delta conversion. So already we have the value of R1, R2 and R3. What we do is just multiply R1, R2 plus R2, R3 plus R3, R1. Just multiply these terms and write in this sequence and find out what are the values you'll get. So if you multiply these terms, so you'll get three different quantities. See that? So if you add and multiply these terms, so you will getting the three different terms 1, 2 and 3. So this 1, 2 and 3 terms is there divided by summation of R del square. And after that you will have this some common term will come out. So finally you will get R12, R23, R31 divided by summation of R del. So you will have got one expression like this. So this expression will help you because after that you have got the previous expression 1 and 1 for R1, R2 and R3. So from 1 and 2 what you can get is that you can have a division of them. So if you divide, so obviously 1, 2 and 3, 1 will cancel out and you want to get R1, 2. So you can have, if you're from 1 and 2 you can have like this. So here we are adding here R2, 3. And R23 is possibly R23 is over here. So I just did it wrong here. This two will cancel out. R23 will remain. So R23 will remain here. So R23 is equal to this entire term divided by the term R1. So here is R1. So this is what we get if we just take equation 1 and equation 2. What is the unique thing about it? R2, 3 when you're writing, it is multiplication of 1, 2, 2, 3 and 3, 1 divided by only R1. Similarly, when I get for R3, 1, it is divided by R2. R1, 2, it is divided by R3. So that is how we are getting this unique terms into picture. And what we can have a conclusion remark is that, see the conclusion remarks. So each resistor in a delta connected, each resistor in a delta connected is a sum of all possible product of Y resistor taken two at a time, divided by the opposite Y resistor. So here your objective is to find this. If you have R1, R2 and R3, then how you will do? Sum of all possible multiplication of this resistor R1, R2, R2, R3, R3, R1 divided by the opposite resistor with R12, that is R3. So this is how, if you will read, you can get what is the value of R12. So all these conversions in the previous figure, we have got a figure like this. That I would like to draw once more. Suppose you have got a figure like this, and in between there is a resistor, and then again is a resistor like this, and you have got a circuit diagram like this. So here you have got some of the picture like R1. Suppose you have RA, RB and RC. So what you can find is that this is nothing but this is like a delta. So if you can convert this delta into a star, if you can convert this delta into a star, like not like this way, rather you will convert like this. From here you can convert this into a star. Now the same circuit that you can see here would look like this. So now you can see this RA, RB and RC has been converted into, this delta has been converted into a star called, let us say, R1, R2 and R3, and this resistor remain like this. So in this way your circuit is now much easier to understand. This is how the circuit flows and current flows, and you can see the circuit equivalent resistance you can easily find, and this is what you help if you can convert delta into star. So that is how the star conversion from delta to star and star to delta is very helpful for solving the complex numericals. Thank you very much, and in subsequent videos we will be doing the numericals based on this.